Hello, this is Mr. Chernoff. I am going to do a question on quantum physics. This is a question about atomic energy levels, and it has a diagram of a fluorescent light tube, the type of light tube you would find on the ceiling of a classroom. It has two electrodes. One electrode is positive and one is negative. Let's say for simplicity that this one is negative and this one is positive. Electrons will shoot off from the negative electrode towards the positive. On their way, these electrons will bump into the mercury atoms, so we have vaporized mercury inside the tube, and the atoms become excited. So the first question, what is meant by the mercury atoms become excited? Well, in collisions between the electrons and the atoms gain energy. So this is the answer from the Mark scheme. Atoms gain energy. That means that the electrons move to a higher energy state, or you can say they move to a state above the ground state. Any state above the ground state is called an excited state. Keep in mind that saying electron shells is not sufficient. Next question. Explain how the excited atoms emit radiation. Here you need to say that when the excited electrons move to a lower energy state, they emit photons, or you can say they emit quanta of electromagnetic radiation. So excited electrons de-excite, and to do that they need to lose energy, and they lose energy by emitting a photon. Now, the next question. Explain why only certain frequencies of radiation are emitted. So, atoms exist in certain or discrete energy levels. You cannot say fixed because electron does not have a fixed energy level. It can move from level to level. The idea that it can only make certain transitions between levels. Each transition corresponds to a certain energy change. So when moving from level 1 to level 2, we absorb a certain amount of energy. And when moving back from level 2 to level 1, we emit a certain amount of energy. So we only have discrete energy changes. The change in energy corresponds to a frequency of electromagnetic radiation. So when you look at this, the energy of the photon is equal to the Planck's constant times the frequency of the electromagnetic radiation. Therefore, the change in energy of the atom would be equal to hf. That means that the frequency of the photon is determined by the difference in the energy levels of the electron inside the mercury atom. Then we need to understand that when the excited mercury atom emits a photon, this photon will be ultraviolet. This is an ultraviolet photon. But then the phosphor coating absorbs this ultraviolet photon, and in turn it emits a visible photon of light. We need to understand why does mercury emit ultraviolet light whereas phosphorus emits visible light. And the answer is quite simple, because different elements have different energy levels. Phosphor has different energy levels to mercury, and therefore it has different spacing between the levels. So there are no transitions in mercury that give you visible light, but phosphorus has such transitions. Therefore, if you excite a phosphorus atom, when it de-excites, it produces a different frequency because it has a different energy change. Thank you.